too cold to drink. If you're done, you can take like a 5-minute break, maybe. Okay. Anybody needs to go to the toilet? No? Okay, let's resume. So, Mika, which one did you look into? Did you guys arrange which one you taking? Each other? No, you just research a lot of them. Okay. So pick three.
I just definition from
Which one?
I give TPS.
D.
IAT.
Which one?
Intake air temperature sensor.
Intake temperature sensor. Okay.
GPS.
So how does that affect your the ECU?
So the IAT measures how hot or cold the air entering the engine.
Okay.
The ECU uses this to calculate the air density of cold air dense, more oxygen, hot air less dense, less oxygen. Since engine burn fuel plus oxygen, then the ECU must adjust the fuel and timing to keep the combustion time.
So colder air, how does that affect the fuel mixture? Will the ECU inject more fuel or less fuel?
Cold air, high oxygen, the ECU more fuel.
More fuel, right? Because more oxygen, more fuel to maintain the same ratio. Okay. What else? Which other sensor? TPS. Throttle. Okay. How does that affect the ECU output?
The TPS tells the ECU how much you are pressing on the accelerator pedal, how open the throttle is.
Okay.
So instead of guessing the driver's demand from the airflow only,
I cannot hear you. I'm sorry. Speak louder.
So instead of guessing the driver's demand from airflow only, the ECU knows the driver wants 20% power or 100% power right now. So it reacts instantly, much faster than waiting for airflow or RPM to change.
Okay. So how does TPS and airflow interact? Think about it. It's a discussion for anyone.
Oh, so the TPS is the intent of the driver. So by the time the driver presses the accelerator pedal, the airflow doesn't register it immediately, but the engine like preemptively put more fuel in it to prevent a lag in the
right.
Yeah.
The airflow sensor will detect the demand, but it's a bit later. Okay. Because first the throttle body opens and then the air vacuum starts to suck in more, and then the airflow sensor will detect that. So what kind of sensor is it? Do you know? The TPS, what kind of sensor? You don't remember from your research? It's a position sensor. Okay, Jason, you have any idea? If you're trying to detect the throttle position, and it's shaped like a round plate. So what kind of sensor would you use to detect that position? Angle, yeah. What do you call that the sensor? Have you taken sensors class?
Yeah.
Third semester, right?
Actually measures the resistance more.
Right. What is it called? Begins with a P. Potentiometer, right? So the angle, it's kind of wiper, right? It wipes across the coils, the long resistance wire, right? And so as the wiper swipe across that coil, then less resistance or more resistance. Okay. How about the IAT? What kind of sensor would that be?
It's a filament sensor. It heats up like uh,
That's the map. The map is a. Now I also forget. Man, you're.
no,
Is it,
I know like the air
hot wire. It's a hot wire anemometer.
Yeah.
That's the map. But the IAT, to my knowledge, most is just a thermistor. A thermistor is a uh, sensor that changes resistance based on temperature. Okay, this one is a bit more complex because you want faster response on the map. Intake air temperature because it responds slowly, like it detects the ambient air, right? And our ambient air is not changing that fast. But the map has to be fast response. Okay. Also detects the temperature somewhat. It has a compensation. Okay. Ivan, which sensor did you research?
Same application, but like I put like more of like an ecosystem because I believe they work together. So I
Yeah.
chose oxygen, total position, mass airflow. I added map sensor and IAT.
Okay, tell me about it. The oxygen sensor.
So the oxygen sensor is before cat and after cat. So it works how um, it's the conversion is ongoing, and with the help of all the other rate sensors, the engine is going to make adjustment. And to correct the adjustment, if it is correct or not, the oxygen sensor come into play. So you have
Yeah.
one after cat and one before cat to know the if the mixture is being burned correctly or not, and then based on the result, it's gonna make adjustment. What's it called? Oh yeah, short-term fuel trim, short-term or long-term fuel trim,
Mm.
and then it's gonna determine it's gonna change either the map for a short period of time. It's if it's either on load or if it's cruising, it's gonna do a long-term fuel trim.
The oxygen sensor detects the combustion products, right? And based on that, you know how balanced you are here on the reaction. So that's the primary feedback for the ECU. Um, now, the the car is not a lab instrument, right? So it does not need that accuracy, at least for low performing engines like economical car. So they have what is called the narrow band oxygen sensor. So it just cares whether, so the output is like, so the voltage out, it just detects whether it's lean or rich, okay? The output is kind of low or high. But a narrow band, a wide band, sorry, this is a narrow band uh, O2 sensor. A wide band O2 sensor will have something like that. And so you know whether I am 13.5 or 13.0. So cheaper cars just do this, right? Because yeah, they just need approximately tuned, but they don't need that fine precision. But sports car will have wideband. Uh, Often tuners will put a wideband oxygen sensor in. Okay, which other ones?
Map sensor. So in the case of atmospheric engine, they also uses a map sensor, and then for turbocharge, you have map sensor, which is manifold output pressure, because turbo delivers pressure to the manifold, and the mass airflow cannot necessarily know the density, and the density of the map sensor is corrected by the air temperature sensor. If the air is colder, the map fuel will change. It will put more fuel because cold air gets more oxygen, and if not, then it will make the required adjustment. So that's this, and then
Is there cars that have both?
yeah, some cars are both.
Okay.
I believe the
My old Civic only have map, the pressure.
I believe the
My
the version
Nissan.
this one has I think 180 or something.
Okay.
Yeah. It's for water breathing.
Mm. My Nissan uses map only. Uh, but the map is before the turbo. So,
And before
right. So it's
so when
not
the turbo is not
operating under
boosting,
pressure.
it uses the map. When it's boosted, it uses the map and
I
bigger
see.
compensation.
Okay. I didn't know that. Okay. Uh, Jason, which sensor did you study?
Vehicle speed sensor,
Okay.
knock sensor, and blood pressure.
Go ahead.
So for the speed sensor, it basically uh, the rotation of the transmission, basically, and there's a by the rotation of the transmission itself, there's a sensor which sense how much rotation, which gives a pulsing to the ECU itself.
Mm.
And by the pulsing itself, the the ECU receive the pulse that are produced by the transmission. It detects like the pulse per second.
Okay.
Which then
What? I mean, interrupt a bit. So, what type of sensor is the PSS? You think?
It's the one with the teeth.
What do you call that?
Hall effect.
Huh?
Hall effect. Hall.
Okay, you can do Hall effect if it has a magnetic tips on the rotor. Uh, they're also optical, right? You can also do optical, but Hall effect are more um, resilient in environment with oil and dirt. Okay. Go ahead, continue.
the other sensor.
Yep, data sensor.
So the next one is the knock sensor. Of course,
Knock sensor. Yep.
so knock sensor is basically detects the abnormal combustion, which are basically knocking.
Yeah.
And
Do you have knock sensor on each cylinder or just in the one engine block?
usually this is one is
Hmm? I think most cars have at least one, but
Me one has two.
yeah, but the performance cars often has one each cylinder, so it can be more specific which cylinder it's talking on. German cars, way too many sensors. Okay, so how will that affect the ECU? What will the ECU do if you detect knock?
there's called piezoelectric crystal.
Oh, that's the knock sensor itself, right?
The knock sensor itself.
Yeah.
When there's a knocking, the engine blocks will vibrate.
Right.
The vibration itself will generate sorry, the vibration will uh, go to the sensor, will generate a voltage to the ECU, which then ECU itself will notice the change of voltage, and the ECU will give a warning to the what's it called? Yeah, the engine light.
Um, I don't think knock sensor will trigger that. But my question is, how will the ECU adjust if there is knock?
The ignition timing.
Timing.
Yeah.
What does it do? Advance or retard?
Uh,
should be it should be
advanced.
Ayman? Because advancing timing is actually more aggressive. Okay, so to advance timing means that you spark it earlier, and so the flame propagation at the top dead center, you'll have more pressure. Okay, if you retard it, because so this is the combustion chamber, right? This is the piston, and it's going up. Okay, so think about it this way, like if I'm pushing this up with my hand, okay, and then I start the explosion while I'm still moving up, it'll create more pressure, right? But if I start this spark late, yes, it's developing pressure as I'm going up, but by the time it reaches higher pressure, I'm already going down. You see? So this is why a more advanced ignition timing will be more aggressive, and it's prone to this knock, because if you have too much pressure, and then you'll start to have little explosions in the chamber, local explosions, and these local explosions will damage your wall, will damage your piston. Very high temperature, high pressure. So what the ECU does when there is knock is it retards a little bit at a time until the knock disappears, and then it kind of have a long-term adjustment value too. In a way, it knows that your engine is at that age, because if you want to eliminate knock, you gotta clean up the combustion chamber, piston, the carbon deposits, or the fuel quality. So I think in the ECU it also remembers. It kind of remembers that last time we did 15-degree advance, you're knocking. So I'm gonna retard it to 13, and it's gonna do that for like maybe a few 100 kilometers until it detects no more knock. Maybe advance it 1 degree. There is knock again. Okay, retard it again. But I'm saying that it has a longer adjustment delay, because at one point it's going to decide, your engine is knocking all the time, so I'm just going to retard it permanently, okay, until you do something with your engine. And so sometimes, this is in older engines or older ECUs, sometimes you need to reset your ECU to clear out this memory that your engine keeps knocking. So after like a major overhaul or something like that, you can reset that to clear out that memory.
The new one also the same. It's
Yeah.
more memory. It has more memory also.
Yeah, it has more memory.
Even if you get in an accident, you change the sensor. The sensor has a serial number on it.
Yeah.
Most of the German codes need to do relearning.
Yeah, you gotta
Even
relearn.
if you flash the memory, it still has the previous sensor's serial number in it.
Yeah.
So you need to put the new, like tell it, yeah, this is a new sensor, and then you will do the relearning.
Okay.
Yeah, it's more. Yeah, even more.
Cool. Camshaft position, crankshaft position. How will that affect the ECU? What kind will it affect? Fuel or ignition timing? How will it affect fuel, you think?
The crankshaft position. It works with, so most of the thing works together with something else.
Yeah.
So the crankshaft position, usually you get the speed also of the crankshaft.
Yeah.
And if it's higher speed, the Was it the timing
Yeah.
or the duration of the injector opening might change?
Right. So it's not the fuel amount, but the fuel timing, right? The timing of the injector opening. Okay, let's watch this. And then
Let's begin with the mass airflow sensor. The mass airflow sensor, or MAF, is positioned in the intake system between the air filter and the throttle valve. It determines the amount of air that enters the engine. Sensor readings are routed to the electronic control unit, which processes all incoming data and transmits control signals to the actuators. Based on the MAF measurements, the ECU determines the best amount of fuel to mix with the incoming air and sends a command to the injectors to supply the necessary amount of gasoline. Moving on to the next sensor. The throttle position sensor, or TPS, is situated on the throttle upstream of the intake manifold. It communicates the position and dynamics of the throttle movement, while the throttle valve angle adjusts based on the position of the accelerator or simply gas pedal. Based on the readings of this sensor, the ECU modifies how much gasoline the injectors supply. If the ECU receives a signal indicating that the throttle valve is closed, air will be provided by the idle air control valve.
Okay, so that kind of bypass the main valve. That's only during idle is that is controlled. I don't always see it these days because many of the throttling is throttled by wire. So the ECU can simply take over the motor on that throttle plate instead of adjusting the idle control valve. That is a source of a lot of maintenance too. I mean, you gotta spray carb clean that little hole. It's annoying, and then your idle is unstable because of that guy.
However, that was an outdated version of the throttle, the cable throttle. Modern vehicles use drive-by-wire throttles, which are operated by an electronic gas pedal via an electronic control unit that uses information from other sensors.
Because of this, you can also kind of program how aggressive you want the throttle response to be, which is kind of nice. It'll be more, fuel consumption will go up though. Hey, you want to play? You gotta play.
Such designs require an additional sensor in the electronic pedal, specifically the accelerator pedal position sensor. While the throttle valve, in this case, is controlled by an electric drive. The electric drive uses the ECU's control signals to put the throttle valve in the right position, including at idle. The idle air control valve is no longer necessary in this design. The next sensor, the crankshaft position sensor, sits next to the crankshaft pulley. This sensor determines the position and rotational speed of the crankshaft. To allow the sensor to measure rotational speed and consistency, a toothed wheel is installed on the pulley. To identify the crankshaft's position, one or more teeth are removed from the wheel. The sensor may also be placed in other locations near the crankshaft, such as next to the flywheel. The electronic control unit uses sensor readings to time fuel injection and the ignition advance angle. The data on crankshaft rotational speed is also sent to the tachometer on the dashboard, while the information on rotation consistency can be used to diagnose misfires. Let's move on to the next sensor, the camshaft position sensor. In most cars, it is located near the camshaft and the cylinder head. The camshaft position sensor determines the position of the camshaft. In the most basic systems, the sensor indicates the location that corresponds to the piston's top dead center in the first cylinder during compression. The ECU analyzes sensor information to identify which cylinder to inject fuel into and ignite, which is required for multi-point fuel injection, where the injector supplies fuel to each cylinder individually. This sensor is also important for the adequate operation of the variable valve timing system. You will find more 3D video lessons in our Car Anatomy online course. Sensor is mounted on top of the cylinder block near the combustion chambers. In four-cylinder engines, it is found between the second and third cylinders. The sensor detects metal knocks in the cylinders, which are symptomatic of engine detonation. Prolonged detonation can cause severe engine damage. Sensor readings help the ECU to determine the optimal ignition advance angle. If the sensor readings exceed the safe threshold, the ECU adjusts the ignition advance angle to reduce engine detonation.
So there are two kinds of knock actually. One is called the pre-ignition. Pre-ignition is basically the fuel and air combust before it's supposed to, before your spark actually sparks, which controls the flame, right? So you want the flame to be controlled. Pre-ignition kind of, combusts by itself. The second type of knock is during the flame propagation. Sometimes fuel impurities or carbon deposits can create local explosions during the flame expansion. And that one is also deadly because that usually happens near those cylinder walls. So these two types of knocks. The retarding of the ignition usually prevents pre-ignition, but these carbon deposits, the type 2 knock, it's kind of hard to adjust. I mean, yeah, it helps the ignition retard, but not that much.
Next, the coolant temperature sensor is located near the engine coolant outlet. For example, in the cylinder head, thermostat, or T of the cooling system. This sensor measures the coolant temperature. Sensor measurements have a considerable impact on cold engine operation, leading to higher idle speed, adjusted ignition advance angle, and richer air-fuel ratios. Such modifications occur until the coolant reaches its operating temperature. When the operating temperature is exceeded, the ECU turns on radiator fans. It should be noted that the fans can be turned on using a separate sensor, known as the fan switch, which is not connected to the ECU. Temperature information is displayed on the vehicle's dashboard.
We will not have time to cover the thermostat, but the thermostat basically regulates whether it's circulating only in the engine or it goes around to the radiator when it cools down the coolant. Usually it's starting to open around 75, 80, but then it's fully open around 90, 90, 92 sometimes. It varies by design, but it's basically a wax that melts and expands.
The oxygen sensor, also known as the lambda probe, is situated in the exhaust system, either close to the exhaust manifold or directly in it, upstream of the catalytic converter. Some designs use more than one sensor. An additional sensor is then installed right after the catalytic converter. These sensors measure the amount of residual oxygen in exhaust gases. The first sensor, called the regulating sensor, monitors the amount of oxygen at the engine exhaust. The second, known as the diagnostic sensor, detects the amount of oxygen at the catalytic converter outlet, evaluating how well it operates. The first sensor's measurements enable the ECU to calculate whether to enrich or lean out the air-fuel ratio based on the amount of oxygen in the exhaust gases. The diagnostic sensor data allows the ECU to detect catalytic converter failures. If it operates inefficiently, the control unit can put the engine in emergency mode. Moving on, the speed sensor is normally mounted on top of the gearbox. The sensor measures the rotational speed of the shafts at the gearbox output, which determines the final wheel speed and the vehicle's speed. One way to measure it is by reading the rotational speed from a special reading gear on the differential. Some vehicles are not equipped with a speed sensor. In this case, the IAS system sensors take over this function, operating in a similar way. Vehicle speed data is delivered to the ECU, which then regulates the fuel supply based on the vehicle's speed and acceleration. The driver can view the vehicle's speed on the dashboard speedometer. The oil pressure sensor can be found at the beginning of the oil gallery, near the filter, or farther down the gallery, in the cylinder block and cylinder head. This sensor monitors oil pressure in the lubrication system. In most cases, the sensor readings do not affect engine operation, and serve only as a warning for the driver about emergency low pressure. If the pressure in the system falls below normal, a warning light will appear on the dashboard.
So the oil pressure is not really affecting the tune at all, it's just safety.
The intake air temperature sensor. It can be combined and housed in the same unit as another sensor, just a mass airflow sensor. It can also be located separately within the intake system. This sensor measures the intake air temperature, which in turn helps determine its density. Based on the readings, the ECU will modify the fuel delivery to achieve the desired air-fuel ratio. We have reviewed the most common set of sensors used in injection and manifold pressure in the intake manifold. Based on the air pressure and temperature in the intake manifold, the ECU can compute the engine's airflow rate, allowing it to regulate fuel injection and ensure an ideal air-fuel ratio, especially when the engine has an external exhaust gas recirculation system. Functionally, this sensor can replace or supplement the mass airflow sensor, providing the ECU with more precise airflow data. This sensor is ideal for measuring airflow and pressure in turbocharged engines, which may have multiple such sensors in the intake manifold and other locations. It is often combined with an intake air temperature sensor. Here are a few other sensors.
They kind of work together, the intake air temperature, the MAP, and the MAP kind of correct each other.
That are not widely used or have little impact on engine operation. Stream of the NOx absorber.
So the postcat is basically for pollution control, not so much for engine performance.
Which is used in compost gases entering the NOx absorber. This is necessary for operation with stratifying a charged engine, as well as for transitioning to NOx absorber regeneration modes and for protecting the system from overheating. The nitrogen oxide sensor measures the concentration of nitrogen oxides after the NOx absorber. If the concentration reaches the threshold, the sensor indicates that the absorber is full and should be switched to regeneration mode. The next sensor is the clutch pedal position sensor. It is located next to the clutch pedal or sometimes on the clutch master cylinder. The sensor signal is used for a short-term decrease in fuel supply to reduce jerks and excessive increases in engine RPMs during gear shifts in cars.
Some ECUs also turn off the AC during wide open throttle. So when you press the pedal to the metal, basically 100% engine power, it turns off the air conditioner compressor to optimize.
With manual transmissions. It can also be utilized for other features, for example, to turn on the cruise control. Next, the brake pedal position sensor. It is mounted next to the brake pedal. In the most basic configurations, this sensor is a traditional switch that activates stop lights when the brake pedal is engaged. In more advanced systems, the control unit activates the stop lights when it gets a signal from the sensor. It can also perform additional functions, such as sending signals indicating the transient operation of an engine, turning on cruise control, and interacting with the ABS system. The next sensor, the EGR valve position sensor, is located in the external exhaust gas recirculation system. In simple designs, the valve position sensor monitors valve operability. In more sophisticated systems, it reports valve position, which improves the accuracy of exhaust gas dosing into the air-fuel mixture. In another configuration, it uses differential pressure feedback EGR sensor. It detects the amount of exhaust gas that passes through the system, allowing for dosage into the intake manifold.
So basically, clean up the combustion.
Next, the engine oil level sensor. Only some cars include this sensor, which primarily informs the driver about the level of oil in the engine. However, in some cases, it can also communicate with the ECU to stop the engine from starting with insufficient oil. The rough road sensor. It is often found at the body next to the shock absorber mount. The sensor detects vertical vibrations in the body, allowing it to recognize it's driving over rough terrain and report it to the ECU. This information is required to disable misfire diagnostics. Misfire is identified when the crankshaft rotates unevenly, which can be caused by bumpy road. In the event of a sensor malfunction or inaccurate data, the ECU enters emergency mode, replacing the missing data with the average data stored in the ECU, as well as data from erroneous or missing signals from the sensors.
Well, I think that's good for the day. I have a couple more videos in the Google Classroom for engine cooling systems if you want to watch it by yourself. Explains how the coolant circuit works. We need to do the post test. So redo the post test from the same Google Classroom, but your score is already good. But go ahead and redo it. You guys already scored very well, but usually do a pre-test and a post-test after the lecture. Do you have a class right after this? You do.
Oh yeah, we do have.
After and
Okay. Well, you can go ahead and do it while you're going to the class so you're not late. Okay? But just press submit on that. But do it like now. Okay? Okay, see you guys.